Triton is one of 14 moons orbiting Neptune, but it stands out quite remarkably compared to the rest, and it's not just because it's the biggest. I hope to shed some light on this long overlooked moon, as there's a lot more to it than meets the eye. From a sad love story in the beginning, as Triton lost its soulmate of sorts, to its tragic future, Triton is a moon that will leave you both in tears and fascination. Named after the son of Poseidon, Triton was discovered on October 10, 1846 by the astronomer William Lassell, just a little over 2 weeks after Neptune was discovered. Given the past technology and methodology, this is quite remarkable and just goes to show just how large Triton is for a moon. In fact, it is the 7th largest moon in the solar system and is bigger than Pluto. A very interesting fact about Triton is that it orbits the opposite direction of its host planet Neptune, called a retrograde orbit. Most moons orbit with the host planet's rotation, like our moon does with Earth, but this is not the case for Triton. In fact, it is the only major moon to do this, and the reason might be quite different than one might expect. The current and seemingly most popular theory is that Triton used to belong to a binary system with another celestial body, likely a dwarf planet. This system orbited around the Sun early in the solar system's formation until it encountered Neptune. Triton's planetary buddy was either ejected deep into space or consumed by Neptune, in a fashion that launched Triton into an irregular retrograde orbit. In this event, Neptune literally catapulted or consumed Triton's soulmate of sorts and forced Triton into a new orbit. You might think that this story is already sad, but it gets worse. It is predicted by many scientists that Triton will crash into Neptune in the far future. This again relates back to the fact that Triton has a retrograde or backwards orbit around Neptune. This means Neptune is constantly slowing down Triton, albeit at an insanely slow rate, but enough to be fatal in the long run. Neptune experiences, like every other planet with moons, small but existent tides from Triton. These tides pull on Triton as both the planet rotates the opposite way and as Triton moves away from them. This causes a tugging of sorts, which slows down Triton ever so slightly. This then causes a very small decrease in the orbit's diameter, as Triton loses a fraction of its orbital energy. It cannot be emphasized enough just how slight this is, similar to how slight our moon is moving away from us a few centimeters every year, around the same rate as the growth of our fingernails. On our timescale, this is such a small effect we probably couldn't even measure it in any of our lifetimes, but on the universal timescale, it will slowly bring Triton closer and closer until in the far, far future, it will crash into Neptune. The estimates range from hundreds of millions of years to billions, but either way, it's widely agreed that it will die one day. On the bright side, this collision will likely result in a magnificent ring system similar to Saturn's, so there might be one positive thing to come out of this after all. Okay, so Triton is screwed to say the least, but don't feel too sympathetic for Triton, as it is not as innocent as it may seem. Triton is most likely responsible for the death of many other moons, as the only other moons left are incredibly smaller than Triton. If you took the mass of all the other moons combined, Triton would make up 99.5% of it. That's right, Triton takes up 99.5% of the mass of all the moons orbiting Neptune combined. This probably means that any other decently sized moon was thrown out of orbit either into space or into Neptune by Triton's retrograde orbit. So, maybe Triton was upset at Neptune for killing its soulmate. That's fair, but enough about Triton's life story and drama. Let's look into Triton itself. What is it made of? Does it spin? Can we live on it? Well, to start, Triton is mostly made of various ices, similar to Pluto. Its surface is covered in a layer of frozen nitrogen ice. Its crust is mostly a mix of nitrogen ice, water ice, and dry ice, or frozen carbon dioxide. It is entirely possible that there are subsurface oceans of water, as it theoretically could be sustained by heat from radioactive decay, but this is not known for sure. And even if there were oceans, the chance of life existing in these extreme regions are slim, but technically not zero. The fact of the matter is, we know a lot of general ideas regarding Triton, but not too much when it comes to the fine details. This is because of two things. First of all, Neptune and Triton are very, very far away. Even some of our best telescopes can barely get a solid, stable picture of it. This image was taken by ESO's Very Large Telescope, and yes, that is its actual scientific name. This telescope is literally, and I quote, the world's most advanced visible light astronomical observatory. To get a sense of just how far away Neptune is, I will showcase the vast distance using a website called If the Moon Were Only 1 Pixel by Josh Worth. As the title says, each pixel is the size of our moon for scale. We start here with our sun. It's a good size, and is what provides us with light. But light travels, well, slow on this time scale. If we were to move through this diagram at the speed of light, we'd move at this speed. You might think, it's not too bad, but look at the bottom of the screen. We don't even appear to be moving at this speed. If we wanted to get to Earth at this speed, we'd have to sit here for 8.5 minutes. And that's just Earth. If we wanted to now go to Neptune, we absolutely would have to skip ahead. 8.5 minutes is tolerable. Maybe listen to a couple of songs, scroll on your phone, but Neptune would take over 4 hours to reach. Yes, at the speed of light. These distances are hard to comprehend, even with a helpful diagram like this, but hopefully at least helps to show just how far away it is. This is the main reason we know very few specific details about Neptune and Triton, as they are so insanely far away from us. But there's more to it than that. One might think, hey, if it's so far, let's bring the equipment to it with probes and whatnot, and that's correct. The problem is, NASA hasn't studied Neptune via a probe since Voyager 2 in 1989. That's around 12 years before I was even born. Computers were still relatively new at the time. The internet was only used by about 1 million or so people, a vast majority being more on the technological and geeky side. This computer was just released, claiming to be an innovation in portable computer technology, despite its weight of over 16 pounds. It's been a long time since we've really gotten a good look at Neptune, because this image from 1989 is still by far the best image we have of Neptune. So until further missions come along to study Neptune and Triton, getting the fine details regarding these celestial bodies will be something left for future studies. NASA hasn't forgotten about Neptune. On the contrary, NASA has actually made several proposals over the past decade, only to die somewhere along the way. Even if its most recent proposal goes through, the Neptune Odyssey won't launch until 2033 and won't even arrive until 2049. But at least this mission has a huge focus on Triton, being one of its main interests. This difficulty of initiating a mission is due to NASA's focus on Jupiter and Saturn for the past while, leaving Uranus and Neptune in the dust. This will probably change in the future, with missions presumably to both Uranus and Neptune respectively, although with a huge recent focus on Venus, a Neptune mission could be further out than originally thought. We have good reasons to study Venus, something I will discuss in a future video, but this leaves Neptune waiting in the dark, in hopes for a mission to finally make its way to the furthest planet our solar system has. Sorry, Pluto.